So today we're looking at hyperbolas. Very similar to ellipses in a lot of ways, but there are some very distinct differences that you need to be aware of. Where it looks almost identical to an ellipse in the equation form, and you have to be able to interpret it differently. Okay? So let's take a look at that. A hyperbola still has, so there's two axes in a hyperbola. Rather than having a major and a minor, we call it the transverse axis. And the transverse axis will fall on what we call the focal axis. So the focal axis is the axis that contains the center, the vertices, and the foci. So the focal axis is that whole line that goes through all of that stuff. The transverse axis is the one that just goes from vertex to vertex and has a set distance. So if I tell you that the transverse axis is 10, then you should know that from the center to one vertex is 5. Your A value is 5, right? Your conjugate axis is this vertical, well, it can be horizontal depending on what kind of hyperbola you have, but it goes through the center, it's perpendicular to your transverse axis, and this value, what do you think this value is going to be? B. Yep, it's just like in an ellipse, where from vertex to vertex is A, and the one that goes through the center that's perpendicular to it is your B values.
Oh, so it's a set length?
Yeah, it is a set length. It's kind of hard to see here, but what's going to happen with that length, you'll see it on the next slide, is that this distance, we're going to have these asymptotes that go diagonally that tell you how wide to make your hyperbola, and that B value tells you your slope. So you'll count up that slope and then over A, and then that gives you how to count out your asymptote. Okay? Are there any questions, though? The two main things here, so the new thing is that, first of all, your focus is now further from the center than your vertex, whereas in the ellipse, the focus was closer to the center, right? Does everyone see that? And then we have these two new terms, the transverse axis and the conjugate axis, so you do want to make sure you know what those two terms mean. Okay? All right. By the way, so you see this line, just that light gray line that just drew in? It's really similar to the definition of an ellipse, where the definition of a hyperbola is a set of all points in a plane for which the absolute value of the differences, rather than the sum. So in the ellipse, the sum of the distances from any point on the line out to the two foci was held constant, and now you're looking at the distance, or the difference between those two distances from any given point out to the foci. That should remain constant. So in other words, if I were to take this line out to this foci and subtract this line from it, that distance that's left over would be the same for any point that I choose anywhere on either of these curves. All right, so the transverse axis, when it's horizontal, and this is where the difference, so let's look up at this equation really quickly. How is this different from an ellipse's equation? You're subtracting, right? Okay, now the difference here is that you know whether you have a horizontal or a vertical hyperbola, not based on which diameter is, or which denominator is bigger. So if you'll remember, in ellipses, we determine whether it's horizontal or vertical by looking for the bigger denominator and seeing which variable that's under, right? That is not the case with a hyperbola. For a hyperbola, you do not care which denominator is bigger. Instead, you care about which fraction is positive. So in other words, I don't care what A and B are here. I know this is horizontal because this fraction with the x is my positive fraction. So that's one of the big differences that you have to understand between an ellipse and a hyperbola. is that when you're determining horizontal versus vertical, it's a completely different thing that you're looking for. Okay? Once I know that it's horizontal, the center is still the same. The distance out to the vertices is always going to be the number underneath the positive fraction. May or may not be bigger than this value. Okay, so this time that doesn't matter. That distance A will always, always, always be underneath the positive fraction. The distance B will always be, and apparently I didn't get to B yet. There we go. So B is always going to be the distance that's underneath the negative fraction. And C is still the distance that's out to the focus, but notice that instead of having a minus here, we have a plus, whereas when I had my ellipse, that was a minus, right? So that's another difference that you want to watch out for, is that if you're doing a hyperbola, it is actually Pythagorean theorem. If you're doing an ellipse, then it's not. It's got the minus sign between a squared, b squared. Now, what I had talked about on the other slide is that this b value tells you where you're putting these asymptotes, right? It counts out the slope for you. So you can see that from the center, one of the equations here is going to be rise b, run a is my slope, right? So when I write the equation of this thing, I've got my slope is b over a or negative b over a, depending on whether I want to be going with a positive or negative slope. And then you can see that the way I did this equation of a line is basically point slope form, except for I took the y minus k and I added the k over to this side, right? So remember, point slope form is usually y minus k equals the slope times x minus h, right? So I have my slope times x minus h, and I just added the k value over. That's it. It's a modified point slope form. And so that's how you guys will find this. You will do rise over run based on your AB values, and then point slope form. Asymptotes, yep. Are there any questions on the asymptotes? Nope. All right. So then what is the equation going to look like? What's going to change in the equation when I have a vertical?
It's going to be negative x.
You're going to have a negative x, so I'll just actually switch those first two terms, right? So that is going to look like this, where now my y term is the positive one and then minus my x term, right? Notice that the a value is still underneath the positive. And again, a might be bigger than, it might not be bigger than b. Okay, so as I start to put my values in here, a is still the distance from the center to the vertex. C is still the distance from the center to a focus. And B is now going to be a horizontal distance that goes out to your asymptote. Now, something did change on these asymptotes. What is the slope now? When you look here, how much are you rising now? A over, which is switched from what it was before, right? When it's horizontal, it's B over A. So that is something to keep in mind, is that it's either going to be A over B or B over A, depending on whether it's horizontal or vertical. You can either just kind of sketch it out, like draw a little sketch like this and kind of think through, okay, if it's vertical, this distance is my A, that's my rise, my run will be B, right? If you want to do a quick little method, I kind of just remember it by, if you're reading the fraction top to bottom, it either spells ab or ba, right? So I think of ba as like a sheep that can only run horizontally. Okay? And I think of ab as like abdominal muscles on a long vertical torso. Okay? So that might help you if you just want a quick version. Otherwise, you can draw it out if you want to actually think conceptually about it. So your equations this time, the only thing that changes on those asymptotes is that, like I said, you have A over B instead because it's vertical. but you still have that point slope form with the center. Any questions on, first of all, how you're determining whether you have horizontal or vertical? Look at the positive term, right? How to find your A, B, or C values, and how to find your asymptotes. Those are kind of the keys here. No? Okay. So let's do a matching. For the first one, what kind of a hyperbola is it? Vertical. What should I look for in my equation? But, do you have that? Hold on, I need to get back out of that annotation mode so that you guys can see it again. Did I give you any with that? No. So, kind of a tricky question there, but for the first graph, can you match it to any of the equations? No. Dun, dun, dun. Gotta watch out for that. Okay. For the second one, though, we certainly should have an option for the second. Yeah? So when I'm looking at this second one, all of these I know are horizontal equations because I've got positive x squared terms, right? All right. How am I going to figure out which one of these it is? The center, right? So my center value, it looks to me like is at -2, -1. So what should I look for in my equation? +2, +1. Where do you see that? A. Notice that it also has, for A, that your distance out to each vertex should be what? Does that match? Yep, 3. Now here I don't have my asymptotes drawn in, so it will be hard to check that B value. We won't. That's good enough for me that I've checked my center and checked my A value. That looks good, right? So for this one, I would say that I have none that match graph A, or I'm sorry, the first graph, but equation A that matches the second graph. Okay, so that's just kind of, again, your quick, do you understand what's going on, but let's actually start to apply it in the more difficult problems. So for this first example, we want to write an equation of a hyperbola satisfying the given conditions. So I want vertices at -1, 0, and 1, 0, and foci at -2, 0, 2, 0. So let's start drawing a sketch of this thing so we can kind of take a look at what we've got. So I have vertices at 1, 0, and -1, and foci here and here. What does this tell you about your graph? It's horizontal. You can see that by where the vertices are in the foci, your cups have to open this way, right? Oops. I went through the wrong point. Vertex, not foci, right? What else do you see from that? Your center is at 0, 0. So knowing where the center is, 0, 0, and also knowing that it's horizontal, how can you start your equation? X squared needs to be the positive because it's horizontal. And I don't need to subtract anything from my x value because it's at 0, 0, and same with the y squared, right? And then that should all equal 1. So now I just need to figure out my a squared and my b squared values. Look at the graph. Can anyone tell me what a is? Yep. A is 1 because it's my distance from my center out to my vertex. What's this distance from 0 to 2? Which value does that give me? That gives me my C value. So then how am I going to find B? Right, so we know that this is actually, since it's a hyperbola, it's Pythagorean theorem with a plus, right? So that means that your B value should equal the square root. And actually, do I need to find B or do I need to find B squared? So I don't really need to do that square root business. I can just do that B squared is going to equal C squared minus A squared. But what is c squared? What is a squared? So b squared is going to be, right. So when I go up to my equation, where do I put the 3? Do I put the 3 underneath y squared or x squared? Right, it's my b value. It should always go underneath the negative term. What should go underneath x squared? 1, my a value squared, right? And then that's all I have to do. I have come up with my equation and I am done. Any questions on that one? Nope. Okay. So for the next one, pause for a second. All right, so for this example, again, we are writing an equation of a hyperbola satisfying the given conditions. This time we're given the asymptotes in one vertex. All right, so what you want to do again is start by, how do we want to start this? What helps?
Well, it's vertical because of the vertex, right?
Yeah, and so for everyone to see that, you might draw a quick sketch of it is kind of what I was getting at, right? So you know that you've got one vertex at 0, 3. That by itself isn't enough to say that it's vertical because it could be that like your other vertex is out here or something. But it's based on where the asymptotes are that solidifies this. So the asymptotes, what's their y-intercept? 0, 0, right? So they're just going through 0. That means that that's where your center is at 0, 0, right? So if your center is at 0, 0, then that means that your other vertex does have to travel 3 down this way. So that's what tells you it's vertical. And that it's opening like this. Okay? Since it's vertical, how can you start your equation? Y squared all over minus x squared all over. Since it's at 0, 0, I don't have to put any centers in, right? Equals 1. What do I know that my a value is? A is equal to, and that's, okay, somebody just said it, and I'm glad you said it. Somebody said 5. Why did you say 5? Because she said, okay, this is a vertical hyperbola, which means that my slope for my asymptote should be ab, a over b, right? And then she looked at her slope, and it's 5 over 4. And so she thought, okay, so that has to be a is 5 and b is 4. But some of you guys said 3, because this distance is 3, right? Remember that the slope is just a simplified fraction. Just because the slope is 5/4 does not guarantee that a is 5 and b is 4. It could be that a is 10 and b is 8, right? It could be any fraction that simplifies down to 5/4. So you don't want to just say that the top number is a and the bottom number is b, because you have to keep in mind that could be simplified, right? So your distance from your center out to your vertex definitely is a. It has to be 3. Okay? But we can find our b value then by using that slope. So I know that my asymptote slope is equal to 5 over 4, and that should be equal to a over b since it's a vertical ellipse, right? But I know that my a value now is what? 3. So now I can just solve this. You can cross multiply, you can do whatever you want. If I cross multiply it, I'll get that 5b is equal to 12, but then I'll divide by 5 so that b is equal to 12/5. Good. Oop, that kind of looks like a 6, doesn't it? Okay. So I now have my a and b value, which is all I need to finish out my equation, right? I don't need to find c. All I'm asking for is the equation. That's it. Okay? So what is a squared? And where does it go? Under the y. What is b squared? Yep. So you can write it like this, or how else can you write that? Yeah, you could write it as 25x squared over 144. I think the book does it like this. On a test, I'll accept either one, whichever one you like better. All right. Any questions on how to make use of your asymptotes like that? No? Okay. All right, so the next couple of examples look at if we want to graph a hyperbola, how do you go through all the steps to graph it given an equation? Okay. First of all, what do you notice? It's not in standard form according to the way that we learned it, right? What do I have to do? Right, so if I divide by 16, I'm going to get x squared over 4 minus y squared over 16 equals 1. Based on this, can you tell me where my center is? Yep. Can you tell me whether this is horizontal or vertical? Which means if it's horizontal because my x, so again, we're not looking at the bigger denominator, right? Some of you guys might have gone to the y because of what I taught you for ellipses. It's not the same. For hyperbola, always the positive term, right? So it's horizontal, which means that when I'm finding my vertices and my foci, I'm going to be adding or subtracting from this x value, right? So in order to do this, though, I need to know what my a, b, and c terms are, right? So what is my a value?
2.
Good. Square root of 4. What's my b value?
4.
Good. And then what's my c value going to be? It's going to be the square root of a squared plus b squared, right? C squared equals a squared plus b squared. What is a squared plus b squared?
20.
So you're doing 4 plus 16 for that, right? Which is the square root of 20, but what is the square root of 20 simplified to? 2 square root of 5. Very good. So now you guys should be able to tell me where my vertices are. Again, you're adding or subtracting which value from the one I circled up here? A. Since this is at 0, 0, you can write that then as plus or minus 2, 0. Somebody asked that earlier. If this had been 3 plus or minus 2, I would not want you to leave it like that because you can actually figure out what 3 plus 2 is and 3 minus 2, right? So I would want you to do that if there was that extra step. But if there is not that extra step, then you can just do the plus and minus. How about your foci? Plus or minus 2 root 5. Good. Yep. And what else do I have to give with hyperbolas? Asymptotes. Very good. So you're going to have y equals plus or minus. For the asymptotes, you always do a plus or minus. What kind of a slope do you have on this one? Ab or ba? Ba, because of, it's a horizontal, like a sheep, right? So you're going to have 4 over 2, but 4 over 2 simplifies to 2. And then you would be doing x minus the center point, but what is your center point? So it's just x, and then you would be adding your y value of the center, but that's also 0. So this is just y equals plus or minus 2x. Are there any questions on how to find all of those different pieces? All right, so then you just go ahead and graph it. So I have my center is at 0, 0. I have vertices at negative 2 and positive 2, 0. When I'm plotting my foci, I need to get at least in between the 2 correct points, right? So I'm going to think about it in terms of rather than 2 square root of 5, I'm going to think about it as the square root of 20. What is the square root of 20 in between? 4 and 5, between 16 and 25 square rooted, right? So it's in between 4 and 5. That's all you need to know. You don't have to get it like the exact spot, as long as it's in between the 2 correct integers. What else do I have to plot? Your asymptote. So you can either start from the center and just count out the slope, or you can start from the vertex and count up by a value of b. It doesn't matter. So like, I'll show you both ways. If I just started at the center and counted out the slope, my slope is 2 over 1. So I'd rise 2 and go over 1, right? So it'd be like right there. And then I could go through those 2 points. If I started at my vertex and went up by my b value, I'd be starting here and going up 4, which you'll notice would have been the next point I would have plotted counting out my slope anyway, right? So either way, you'll be fine, as long as you count it from the right spot. And then we'll want to do that in the negative direction as well. So first of all, I'm going to kind of make that be a dotted line going through those values. So I have my asymptote. And then going the other way again, however you want to do that, plot your point, draw your asymptote going through them.
Could you just go from the vertex and count like up 4 and then down 4?
Yeah, that's the second way I said. So I said you can either count at the center and count out the slope,
Yeah,
or you can start at the vertex and count your b value.
up and down.
Yeah. All right. We now have everything we need. The asymptotes give me the width. So remember that for a parabola, in order for you to determine the width on the parabola, what did I have you do? Find the vertex and then those 4 points that straddle it, right? So the parabola is a little bit more work to find whether it's skinny or wide. Whereas for the hyperbola, you don't need to plot extra points. You just need to go out to your asymptote. So like I'll start sketching this, go through my vertex, but then follow out to the asymptotes on either side, right? Whoa. Sorry about that. So it looks something like that. Any questions on that? Okay. Let's do one more. So for this one, we have a little bit more work to do, but again, we should be very confident with our completing the square skills at this point, right? Well, all right. How do I know I have to complete the square? Because I have the linear x and y terms, right? So if I have both a y squared and a y term, I'm going to have to complete the square. And I have y squared and y and x squared and x. So the first term I'm going to complete my square on are my y values. So I'm looking at this and I'm looking at this. If I'm going to start to complete the square in those, what's my first step going to be? Take out a 9. Very good. So you're going to take out a 9. You're going to be left with y squared minus 6y. And then if you're completing the square in this, what are you going to add to it? You're adding 9. Good. And then minus, looking at your x's now, what do you have to do? Take out a 4. Yep, and the minus sign is being pulled out as well. So when I'm looking at what's left, I've got x squared plus, since I took the negative out of the 8, 2x, and then what am I adding in? Plus 1. Okay, so that equals, and I'm going to subtract that 41 to the other side, but now I have to also balance out my equation. So the fact that I had added in that 9, but I have technically 9 of them, right, or 81 of them. And then, yeah, the minus sign has to be attached here. So you have to think about the fact that you've added 81 in, but you've subtracted, not added 4, right? So how much have you technically added? You've technically added 77, because you had 81, but then minus 4, right? So that means that I need to add 77 onto this side. All right, so now what does this look like? I've got 9 times y minus 3 squared minus 4 times x plus 1 squared equals 36. But what's my next step going to be? Divide everything by 36. So I'm going to kind of do this all in one go here. So I'm going to, when I divide by 9 by 36, what am I left with? 4, so then I'm going to erase my 9 out front, right? And when I divide 4 by 36, what am I left with? 9, and that gets rid of the 4 out front. Okay? And then what is the 36 left with? 1. Very good. And so my equation is now ready to go. All right. What is the first thing that I want to find? Good. What is my center? Good. -1, 3. Which value will I be working with on that? Why the 3? Right, my y value is positive, so it's a vertical ellipse, which means that the 3 is going to be the value that I'm adjusting for the vertices and the foci, right? So then, before I can do that work, though, I need to know what my a, b, and c values are, right? So what is my a value? 2. What is my b value? My c value is going to be the square root of a squared plus b squared, so the square root of... Okay? So, based on that, where are, well, let's not do foci, let's do vertices first. You are adding and subtracting 2 from that 3, right? So when I subtract 2, I get -1, 1. And when I add 2, I get -1, 5. So those are my 2 vertices. How about my foci? -1, and then I'm at 3, and I can write this one as just a plus and minus square root of 13. Since I can't simplify that anyway, I can just write it as one big old thing. What else do I have to find? Asymptotes. So my asymptotes are going to be y equals plus or minus, good, don't forget that part. If you only give me a plus version, you're going to lose points. Is it a over b or b over a? A over b. It's a vertical app, right? So a value is 2 over your b value is 3. Do I have a center that I have to do now? Yep, so you would do x plus 1 for the center. You are not squaring this. A lot of people get in the habit of squaring it, but it is a line. It is not a parabola. We're talking about the asymptotes, which are linear, right? So just x plus 1, and then tack on your y value plus 3. And that's it. So now I have to draw it. Okay? So I have a center at -1, positive 3. I have vertices at -1, 1, and -1, 5. My foci, it'll be easier for me, rather than to try and think of what 3 plus the square root of 13 is just to think about what is the square root of 13 and count that out from the center, right? So what is the square root of 13 between? In between 3 and 4, right? So I count out in between 3 and 4 from my center point. So I go up 1, 2, 3, and somewhere in between that and 4, right? And then down about the same amount. Oops. And then what else do I have to plot? Asymptotes, which again, you can just count your slope off the center, which is what I'm going to do. So I'm going to rise 2 and then run 3 in both left and right directions, okay? And then I'll draw my 2 lines going through those guys. That gives me my width, so I can now draw my hyperbola in those regions. Questions on that? Okay. All right, so just like we had the eccentricity of an ellipse, we've got eccentricity of hyperbolas. It's the same thing as it was for an ellipse. It still is your C value over your A value. You can read through this. I kind of went through this logic for the ellipse. It's a little bit backwards from the ellipse, but it'll be good for you guys if you want to kind of think through why it would be that if E is close to 1, why would the hyperbola be narrow? So again, what you kind of want to think through is if E is close to 1, then that means that your C and A values are really close, right? And if your C and A values are really close, then your B value would have to be very, what? Small. Because if C squared equals A squared plus B squared, and A squared and C squared are already close, you would have to add very little onto A squared to get C squared, right? So B would be really small, and B tells you how far out to go from your vertex, right? And if you're going out just a very small amount, it's going to make a really skinny looking arc. And then vice versa for the 0, if you have a 0, then that means that your C and A values are far away, which means your B value is big, which will make it wide. That's kind of what you're thinking through there. But let's take a look at how we would just use this in terms of here's your eccentricity, use it to your benefit. So for this one, we want to find a hyperbola that has the vertices at -1, 3 and -1, 7 and an eccentricity of 4. So as usual, kind of start by sketching out what you've got so that you're aware. So, let me draw that a little lower. So I'm at -1 on my x-axis, and then I've got a vertex at -1, 3. And a vertex at -1, 7, right? So first of all, what does that tell you? It's vertical, so you know it's doing this. And what else do you get from that? Center is at
-1 and
5. Yep, right there. Okay, so I can start this. Which variable am I putting at the front of this? If it's vertical. So you're going to do y and then -5 for your center's y value, right? Minus and then x plus 1. And now all I have to do is figure out what my fractions are. So can you guys already tell me what your A value is? Yep. So your A value you can see here is 2, distance from the center out to a vertex. So that means what am I putting underneath my y? Yep. So underneath my y I put my A squared. And now I have to find B squared. How am I going to find B squared? Use your eccentricity, right? So your eccentricity is 4 over 1, or just 4, right? But what does your eccentricity, what does it represent? Right. So if E is equal to C over A, and your A value is 2, then I can set that fraction equal to 4 if that's what my eccentricity is, right? So then C is equal to 8. Very good. Okay, but that still isn't what I was looking for. I'm still looking for b. So b is going to be, and I'm actually looking for b squared, right? So I can kind of simplify my life just a little bit by recognizing that b squared is going to equal c squared minus a squared once I readjust my Pythagorean theorem, right? But what is c squared? What is a squared? So b squared is, and that's what I would put underneath my second fraction. And then you are done. Any questions on how to use the eccentricity? Okay. Here's your homework. I think, what time do we get out of here? 49. So you've got a little over 20 minutes. You can get a good way through this because these problems should go fairly quickly. Again, remember, if you want to do your homework corrections to this before the test, you'll have to see me outside of class. Okay?